So Python, as we know about the Python is one of the most popular programming language. It is very simple and it is very powerful and driven by community that's contribute to open source project also. Okay, so the many Python uh, uses are why the programming is so popular. You can build software, you can develop any web services, you can perform data analytics, and if you want to develop any visualization and train the machine learning models for free, so you can use the Python programming in a very easy manner, very simple manner. Okay, so the list of Python tools mentioned in this lecture will help whenever you want to develop any Python programming as a beginner. You want to start the Python programming, so we can discuss the Python tools here. Okay, so you can start your Python development journey as a beginner. Okay, it will also help data professionals also and data developer also. That will become the very productive. Okay, so whatever stages of your Python journey you are at right now, these tools can help you make the most of the languages. So first we discuss about the Google Colab. So getting started with Google Colab, the realm of the data science and machine learning having a powerful tool, flexible and accessible computational environment is essential. Google Colab, short for collaboratory, okay, that's offer just that. It's a free cloud-based platform that allow us to write and execute Python code in a Jupyter notebook environment. Okay, making it an excellent tool for both beginners and experienced developers or practitioners, you can say. Okay, so what is Google Colab actually? Google Colab is a product from the Google research that allows anyone to write and execute arbitrary Python code through the browser. Okay, we already discussed about the so many program in previous lecture on the Google Colab. Okay, so you can go through your previous lecture also. It's especially well suited for Python, sorry, machine learning and data analysis and educational purpose. With Colab, you can leverage the power of GPUs, that means graphical processing unit, and TPU, that means tensor processing unit, for free, making it popular choice for resource intensive task. Okay, why use Google Colab? So there are so many reasons. First one is free access to powerful hardware, but in a limited size, you can say. Okay, uh, Google Colab provides free access to GPUs and TPUs, which can significantly speed up computations compared to the standard CPU. There's no need to required installation. Being a cloud-based service, there is no need to install any software on your mobile, oh sorry, your computer. All you need is a web browser and Google account. Collaborative features just like Google Docs, Colab notebooks can be shared and edited by multiple users in real time, making collaboration seamless. Integration with Google Drive, you can save your notebook directly to your Google Drive, ensuring easy access and sharing. So that is one of the benefit whenever you want to use the Google Colab. Okay. Step number one, how can we start the programming on Google Colab? So step number one, accessing Google Colab. Open your web browser and go to Google Colab, and then you can sign in with your Google account. If you have not already. Note you are encouraged to use the Google account you have had for a while. Setting up a new Google account can sometimes limit you when utilizing GPUs in Colab. Second step is creating a new notebook. Once on the Colab homepage, click on the new notebook button. Okay, so you might get a pop-up like a image below where you can click the button new notebook in the lower left corner. If not, you can always click on file, then you can go with the new notebook. Look like this. This is the framework image. If you want to go through Google Colab, so you can just open the open notebook. If you want to open the recent notebook, so you can go on the recent button, just click on that, you will get the recent file. Okay, and second one is this will open a new tab with fresh notebook. You want to open fresh notebook here, so you can just go on the file option and just click on that. You will get the so many options are there. You just click on the new notebook and you will get the new notebook here. Okay. Step number three, changing runtime. When running deep learning scripts, you will need to change from CPU to GPU. To do this, click Runtime, change runtime types, then select T4 GPU, then click Save. So you can change runtime types, okay, as a T4 GPU, just like this image. Just click on the runtime and go through the change runtime types. Note, you are encouraged to sign up to the Google Colab with an existing Google account. If you create a new Google account, your GPU access may be cut off. Okay, so changing runtime, if you want to select CPU, you want to select G4 GPU, so you can go through G4 GPU T4s and save it. Step number four, run Python on your notebook. To execute Python code, click the run button to the left of the cell. This is the circle with the triangle inside. Look like this. You can see this is the example to print the hello world on the Google Colab environment. Okay. In this, to change the title of your Google Colab notebook, so just click on the title and rename as you wish. Okay. Just look like this image. If you want to change the title to name, so just click on that and you can give the some name for that file. Yes, to save a copy of your notebook on your local computer. So you can do that. You can navigate to the file and go through on the download button. And there are two options. If you want to download this file .py format, if you want to download this file .ipynb file format, so you can download it, okay, and save on your local computer. Yes, another option is Spider is also there. Getting started with Spider. So Spider is very powerful and easy to use environment that is written in Python for Python. What make it special is the diverse functionalities that it offers. For example, it provides the easy debugging, advanced editing, okay, aesthetically pleasing visualization technique, interactive executions, and so many more. So if you want to work on that, so firstly you need to installation of Spider. Installing Spider is a relatively simple task on Linux, Windows, or Mac OS. However, Spider can be used without installation using Binder. one can work with an identical copy of a spider. So binder you can use. It runs on the web and require no installation. To get it started, just visit the spider page on binder and start using spider online. The Anaconda Python distribution includes the spider ID. All you have to do is open an Anaconda navigator and scroll the spider which will under the home section and press launch. Another method to launch Spider is by opening Anaconda prompt, then typing conda active base followed by the spider. So uh, there are the option whenever you want to work with the spider. So there are three way. Okay, you can if you want to choose the installation of the spider via Anaconda, so you can use that distribution. And if you want to install spider on Linux, Windows, Mac OS, you can install directly. If you want to use online as a binder, so you can use that. Okay. When you first open the Spider ID, you will observe that the screen is divided in three sections of panes. So first is the editor. Okay. It is in the editor that we will writing the code. Spider support multiple languages, multi-languages you can say. The editor allows writing code of different languages and integrates several powerful tools for easy to use and effective editing practice. Some of the editor's use that include highlighting syntaxes, seeking the help of an unknown command, and real-time code analysis, function and class browser, horizontal and vertical splitting, and so many more. Look like this. There are three console. You can see here console 1A, console 2A, console 4A. Okay. So each console demonstrate a front-end light interface that is seamlessly connected to a kernel in a backend. One can also connect to external, local, and remote kernel. You can say including Jupyter Notebook. This option is available as connect to an existing kernel option under the console menu. Okay, so look like this picture. You can go through the console button and connect to the existing kernel also. Okay, just like this. Next one is display. The last pane has different subsection. First one is editor, second one is console, third one is display. So last section has different subsection. For example, variable explorer. On this panel, we can see all the variables, including all global object, variables, class instances, and more. These variable has been initialized in the code. It helps us track the variables that we have introduced in this code. This is useful especially when the code is long and complicated and involve numerous variables, data types, varying data types. The variable explorer also provide useful information like the name, size, type, and value of each of the defined variable. Another section is of help. Under this section, pressing Control plus I over any syntax, say print, give us the complete documentation reference on the number of argument it takes in, the kind of output is produced, and various other informations. This allows easy access to the documentation from Spider directly without any interpretation from the workplace and without actually going to the documentation website. Furthermore, Spider's tutorial can also be accessed from here. Okay, we will provide the link also if you want to access, so you can access. Okay, you can see here there is a tutorial link is also available whenever you want to access tutorial of the spider. So you can just click on that, okay, and you will get the tutorial whenever you want to learn the spider. Okay, so you can see this is in this section. So similarly, the plot section displays all the plots. Plots is also there that have been produced in the code that has been written in the editor or produced by the variable explorer. Finally, the file section displays all the files of the directory we are currently under. It helps navigate amongst various files that we might have under one project, and also set up a directory that is essential to run a .py file. You can see here, this is the display section. Here is the help variable explorer, plot, and file. Okay, you can see here, this is the pictorial presentation of the section also. Okay, one is the editor, second one is the display, third one is the console. Editor, display, console. Managing project is also there. To create new project, navigate to the project tab on the header dashboard and then press the new project drop down. You have two options of the creating the completing a new project and choosing one from the directory. In the latter case, one has to specify the name and path of the project. After the project opens, a project pane is displayed and the pane show a project tree that contains files and directories in which the project is presented. Using version control, the project pane is integrated with the basic functionalities of the Git Git distribution version control system. You have the option to commit files, browse various files via the Git command. For this to happen, the project must have a Git repository and Git commands must be specified on the system path. Okay, debugging is also there. Debugging option is available in Spider through the IPDB debugger, which is present in the IPython console. Okay, so this helps us view the flow of executions, breakpoints, and even control them. It is possible to fully control the execution of the debugger from the debug menu using keyboard shortcuts, together with the console commands of IPDB. You can see this picture. Okay, you can set and clear the breakpoint also. You can see the arrow. Code analysis. There is a pane in Spider. Help us analyze your code and also tell us the potential mistakes involves. It detects if there are any style issues, potential bugs, version compatibility problem in the code. Depending upon these factors, it gives a quality score. The lower the score, the higher are the chance of the presence of potential bugs in the code. It even provides the score of previous execution. On comparing both the scores, we will give cat an insight into the whether the recent changes made were correct or lead to addition of the bugs. You can see this picture. For the code analysis, there is a section for the code analysis. You can analyze it. Okay. Help section is also there as we discussed. In this section, help section is also there. Help and comprise various documentation, tutorials, shortcut tricks, and many more functionalities that might come in handy to the beginner. It is highly recommended that new user navigate all the drop-down present in the help pane to get a more lucid idea about using Spider ID and its various features. You can see this picture regarding the helps. Help section is there. Getting started with Orange. Data mining is used to build prediction model based on the historical data. They can help in making decision and prediction future trends. Orange is a framework for data visualization, machine learning, and data mining with the front end of the visual programming. It is very helpful for analyzing big data set and support visual programming tool for the data mining. Orange is an open source scriptable environment for quick prototyping of the latest algorithms and testing patterns. It is a group of Python-based modules that exist in the core library. The analysis is achieved by connecting that perform various functions such as reading file, displaying statistics on features, constructing models, evaluating, etc. Orange is great software package for machine learning as well as data mining also. Orange widget and graphical user interface to Orange data mining, machine learning techniques. They are the various components present in the Orange. There's various categories like data, visualized, model, evaluate, and so on. Widget is for essential functionalities like displaying data table, aligned to selection features, data reading, data element visualization, training, predictors, and comparison of learning algorithm, etc. How to use workflow in the Orange? Orange workflows consist of components that read, process, and visualize data. We can communicate by sending information along with the communication channel. An output from one get widget is used as input to another. This makes a workflow. Let's start by creating a simple workflow for any dataset. Orange provides a few inbuilt dataset. You can use one of those and import one of your choice. I have used here data set, a heart disease dataset. This data is on the presence of heart disease in the patient. Look like this. You can see the picture. Okay, there is a source file of the dataset we have used here. That heart disease dataset we use it. The workflow is designed in such a way that data from dataset is sent to the data table to view the data in the tabular form, to distribution for creating a distribution, and a scatter plot to plot from the dataset. To create this simple workflow in Orange, step number one, load the dataset using the file widget. And step number two, create links from file to data info, data table, distributions, and a scatter plot. Look like this. You can see here. This is what an orange workflow looks like with each widget serving as an individual purpose. On the left hand side, you can see a panel containing all the widgets that you can drop and drag onto the workflow canvas. Look like this at the right hand side. This link seen between all the widgets are to connect them and have to data flow through the workspace. To load data, drag and drop the file widget from the left pane and place it in the canvas. Double click on the file widget and select the desired dataset. Look like this. This is the file and data info. Okay, this is the widget which will we can which we can select from the left hand side. Okay, and this is the data set which are having some attributes are there. You can see here. This is the information of the data set. 303 instances are there, 13 features are there, 2% missing values are there, classification categorical classes with two values data set, and zero meta attributes are there. So these are the information. How to do basic data exploration like data distribution, data information. To get information about the loaded data, we use the info. It shows the data set name, size, features, description, row count, column count, and targets, and data attributes in the data set. You can see here in the right hand side, data set name is heart disease, data set size is row 303 and columns are 14, and features, categorical features 7 and numerical 6, targets, categorical outcome with two values, meta attributes are none, location data is stored in memory, data attributes. Okay, so these are the basic thing as data information. To view your data in tabular form, use the data table widget. Drag and drop the widget to the canvas and create a link from the file widget to the data table widget. You can see here in a tabular format, there are the features, okay, age, gender, chest pain, rest, SBP, cholesterol, and all. Okay. Data distributions, other it is used to get graphical representation of the data set values. Here one can see Zilli view distribution for different features from the data set. You can observe the distribution based on age and the given snapshot. Okay, similarly, you can view distribution for gender and cholesterol, etc. also. So this one is representing the age data distribution. Okay, for given data set, heart disease data set. Another one is the scatter plot, which is to plot different kind of features pair. Here, scatter plot is plotted for the features pair for cholesterol and age also. There are the two features we are taking here, age and cholesterol. On the basis of these two features, we are generating the creating the scatter plot for both of these. How to load your data in Orange and how to load external data from API in Orange. I said before, Orange allow you to use either one of the inbuilt dataset or any dataset of your choice. The file widget allows you to load data. You can directly choose the dataset you want to use by selecting the file option as source. Else, if you want to load external data, you can simply select the URL option for the source and paste the external dataset link here. Okay, so there are two options if you want to upload directly. Okay, if you want to use uploaded data, okay, so you can use it. If you want to use external data, so you can also use that as simply give the URL option as a source. Another is Jupyter Notebook. The Jupyter Notebook is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, narrative text. Jupyter has support for overall 40 different programming languages, and Python one is one of them. Python is a requirement for installing the Jupyter Notebook itself. There are the options Python 3.3 or greater and Python 2.7. Jupyter Notebook can be installed by using either of two ways described below. Look like this. Install Jupyter Notebook with Anaconda. Install Jupyter Notebook with PIP. Command to launch Jupyter Notebook. Jupyter Notebook look like this. When the notebook open in your browser, you will see the notebook dashboard, which will show a list of the notebooks, files, subdirectories in the directory where the notebook server was started. Most of the time, you will wish to start a notebook server in the highest level directory containing notebooks. Offer this will be your home directory. You can see here creating a Jupyter notebook. Now on the dashboard, you can see a new button at the top right corner. Click it to open a drop down list, and then if you will click on Python 3, it will open a new notebook. Look like this. Renaming Jupyter Notebook. We can notice that at the top of the page is the word untitled. This is the title for page and the name of your notebook. We will change the name by simply clicking on it. Okay, look like this. You can, if you want to rename your notebook, so you can give the name of that particular notebook. Run and debug Jupyter Notebook code cell. Let's try adding the following code to that cell. Running a cell meaning that we want to execute the cells contained. To execute a cell, you can just select the cell and click the run button that is in the row of the buttons along the top. It's toward the middle. Look like this picture. Okay. There are so many options are there. File, edit, view, insert, cell, kernel, git self, and logout and all. So you can see here and use it. So menu items are there. A list of menus which can be used to perform various functions like file. The file menu in the Jupyter Notebook allow you to perform action like creating and opening notebooks, saving your work, exporting notebook in different formats, managing checkpoints, and closing notebooks. Second one is edit. The edit menu in Jupyter Notebook provides various editing options for the cell within your notebook. Like you can cut, copy, paste, delete, merge, split, and manipulate cells using these edit functions. View. The view menu in Jupyter Notebook provides options to control the appearance and layout of your notebook interference interface, allowing you to customize its display to your preference, preferences and needs. The insert menu in Jupyter Notebook contains option for adding new cells and other element to your notebooks, allowing you to insert code, text, and various types of content into your document. Cell. The cell menu in Jupyter Notebook provides option for manipulating individual cells within your notebook. You can use it to run, delete, modify cells, as well as change their cell type, look like code markdown. This menu is essential for cell level operations in your notebook. Kernel is also there. The kernel menu allow you to interpret and restart the computation process. Reconnect to a kernel and change the kernel. Programming language like environment, okay, for your notebook. It is crucial for managing the execution state of the Jupyter notebook. Visit menu in Jupyter Notebook is used for working with interactive visits, which are graphical elements that enhance the interactivity and user experience of your notebook. You can use this menu to create, display, and interact with widget like button, sliders, text boxes, and more. Another one is help. The help menu in Jupyter Notebook offer documentation and resources to assist user in understanding and using Jupyter Notebook effectively. Open a terminal in Jupyter. To open terminal, go to the home page and click on New and select Terminal on the drop-down list. Look like this picture. Viewing what's running. The home page of your Jupyter server has two other tabs, running and clusters. The running tab will tell us which notebooks and terminals we are currently running. This is useful for when you want to shut down your server, but you need to make sure that you have saved your all your data. Adding rich content in Jupyter Notebook. In Jupyter Notebook, we can add rich content to your notebook to enhance their interactivity and visual appeal. Rich content exclude include text, image, latex, equations, HTML, and multimedia elements like audio and video. This capabilities make Jupyter Notebook a versatile tool for data analysis, research, and education. Types of cells in Jupyter Notebook are there. Jupyter Notebooks provide several cells types, each with its own purpose and functionalities. This cell type enable you to create, edit, organize your content within the notebook. Here are the main cell types in Jupyter. Code cells. Code cells are used to write and execute code. You can enter programming code in various languages such as Python, Julia, or R and execute it within the notebook. The output of the code is displayed below the cell. To run a code cell, press Shift plus Enter and click the Run button in the toolbar. Markdown cells are there. Markdown cells contain formatted text using markdown syntax. You can create heading, list, table, links, making it suitable for documentation and explanation. To render the markdown content, press Shift plus Enter. Raw cells are there. Raw cells are used to include unprocessed raw content. The content is not evaluated, formatted, or executed. Raw cells are typically used for including content like latex equations. Heading cells are type of markdown cells that is used to structure your notebook. They create section, heading, and subheadings, which are helpful for organizing your content. Raw NB convert cells. There are similar to raw cells, but are intended for content that will be converted into another format when the notebook is exported. Exporting the Jupyter Notebook. In Jupyter Notebook, we can export our notebooks in various formats to share with other people. Here, how we can export notebooks. The format available are HTML, LaTeX, PDF, Reveal JS, Markdown, and restructured text and executable script. So there are so many tools are available uh, like Google Colab, Jupyter, Python 2.7, more than Python, more upgraded versions are also available. You can use Jupyter, you can use Google Colab. So Google Colab actually there is the open source platform. There we can use the whenever you want to develop the Python programming. Okay, as a like simple whenever you want to start as Python program as a beginner, so you can use that tool also. You can use and this tool in this tool whenever you want to done any programming. So no need to save as no need to save as a source in your local computer. It's directly save in the Google Drive. So that is the major benefit in Google Colab. Whenever you want to use the Google Colab, so no need to store, no need to save as a source of your program in your local computer. If you have the Google Drive account on a Google account, as in say, so you can use. Okay. Another thing is there is the available GPU and TPU also, but limited size. Okay. For example, if you want to use the data set that has a size 10 GB data set. Okay. So this is not possible to run this use this data set. Huge amount of information are available like 10 GB. Okay. So this is not possible. But if you want to use the less amount of information, like if you want to use 1 GB data set, so you can directly uh, upload that data set. Okay. So that is another benefit. If you want to share this project, if you want to develop any project on the Google Colab, and if you want to share with me, so you just share Google Drive link along with your Google, along with your data set also, along with your code also. Okay, so that's a part of the Google Colab. And another thing is about whenever we want to use the orange. Okay, so that's a tool whenever you want to interact with the visualization with the data. Okay, whenever you want to analysis data analysis perform in the data set. We already taken one of the example of the data set that is the heart disease data set. Basically, orange tool we use for the data analysis purpose, data visualization purpose, or the data mining. What is actually data mining? Have you any idea about the data mining? Extract the meaningful information. Okay. So data mining is a part of the machine learning, but machine learning is no part of the data mining, as we can say. Data means what? Information. Okay. And mining means what? Extraction, you can say. Okay. So extract the meaningful information. You can say data mining. Okay. So whenever we want to deal with the data analysis with any data set, so you can directly go through the orange tool. That is the very simple, that is very powerful, that is very easy to understand. Okay. So another thing is Jupyter Notebook. As we said, Jupyter Notebook, whenever you want to use the Jupyter Notebook in your local computer, so as a host, you can run the program on your local computer. Okay, and that is very simple. Whenever you want to run any code on a Jupyter, that's very simple. Look like this. There is the terminal in Jupyter. Look like this. You can see here. That is a pictorial presentation of the home page of the Jupyter, and click on new and select the terminal from the top down list. Okay, so viewing the what's running. So if you want to use it, so you can see this picture that is representing the what's running here right now. So first notebook.ipyb. That is there is one another thing is in Google Colab and Jupyter. There is the though there are two options are available. If you want to download your program in .py file and .ipyb file. .ipyb. Okay, so in that format we can download it. Another thing is if you want to trying to add following code in that cell, so you can also use this. Okay, so this first page, okay, look like this. If you want to print, this is your first notebook. Just simply use the print function here. No need to any another another thing is add here. Print your name. So print function we have used here. My name is Shivendra. So we use their print function and we write here my name is Shivendra Dubey. Just click on that, you can execute it and you will get the print Shivendra Dubey. My name is Shivendra Dubey. If you want to add two number, look like this. If you want to add two number as a firstly we will store the variable, use the variable to store that the number a is equals to 3. That means 3 is in A. A and B are the variable. B is equals to 2. That means 2 is in B. Then after that, you want to add the number. So print function we have used and print A plus B. Print A plus B. Hit on the run and you will get the answer 6. Okay. So if you want to develop any code in the Jupyter as well as any Colab as well as Spider also is there. Already we discussed about the Spider. Spider is very easy and very powerful. tool, I already use this spider tools. Okay, uh, whenever you want to install it, so you can install it. Whenever you want to use as open source, sorry, online modes, you can use Blinder, Binder, and go through with the spider. So you can use the, okay, but this is very powerful, interactive tool and easy to understand tool. Okay, getting started with the spider. Okay, so if you want to get some tutorial about the spider, so there are the three sections which we discussed, okay, in this lecture. So tutorial is also there for the beginner. If you want to learn something new, if you want to learn in depth about the spider, so you can just use the this tutorial. Okay, so there are the so many tools are available whenever you want to uh, do the programming on the Python, so you can use it. Okay, thank you.
Then level 2 is active. Level 2 is clear, then level 3 is active. It means some condition is provided to execute. If the one condition is true, then the next condition is execute. Otherwise, if the first condition, if you are not clear the level 1, then you are not eligible or you are not enter into the level second. Same thing. How it is takes place in Python. So in Python there is nested if statement to execute these type of statement, or this type of a nested if is an if statement that is target of another if statement. It means when a if statement is execute, then it target or it transfer the execution pointer to the next if, or you can say another if, which is inside the previous one or previous if. Nested if statement means an if statement inside another if statement. It means a if statement is within another if statement. Yes, Python allows us to next. Python and other programming languages also allow to, but we will discuss about only Python language. Python language allow us to nest if statements within if statements. That is, we can place an if statement inside another if statement. For example, you can see syntax: if condition 1 execute when condition is true, and the condition 2 is also given. Condition 2 when will be the condition true execute once condition 1 is executed, then condition 2 will be execute. If the condition 1 is false, then your execution block or your execution pointer terminate the inside block. It is not enter into if is block. Executes when condition 2 is true. If condition 1 is true, then this statement execute. Condition 2 is checked. If the condition 2 is true, then this statement execute. The if the condition 2 block 2 is end, and then block 1 is in. It means a if statement executed after another if statement. That is known as nesting of a nested if else statement. That is, create a nesting of if statements. For example, I is 10. If the value of I is equal to 10, first I is equal to 10. If the I is less than 15, I is smaller than 15. If I is less than 12, I is smaller than 12, 2, it means all three statements are execute because of I is equal to 10, I is less than 15, and I is, once you check the first condition, then check second condition, and then check third condition, and all three statements are executed because of all three statements are true. Once a condition is false, then you can not execute the inner statements. Here the concept of inner and outer statement. Inner statement, a statement which is present inside of any if statement. Suppose the second one, I is greater less than 15, is present inside the if I is equal to 10. If any value provided to I is not equal to the 10, this condition is not true, and your execution pointer never enter into this. Then never check the I is less than 15 or whatever I is less than 12. For example, we will demonstrate it in a Google Colab. Suppose, for example, write here I equal to 10. I write the same code, whatever I explain you in a example. I equal to 10 if I equal to double equal to is check for which equality. If the I value is equal to 10, then print I is equal to 10. And if I is less than 15, print I is smaller than 15. If I is less than 12, I is less than 12, then print I is smaller than 12 2, and just execute this code. You can see all three statements are executed because of once you check if I is equal to 10. Yes, if the first condition is true, the statement will be execute, and then check the next condition. If I is less than 15, then if condition true, then execute, then check the next condition, and it's nesting. One question arise here, sir, up to which level we can nesting? Suppose for example this is 1 2 3 level. You can take any number of levels like 10 20 15. It means 1 2 3 4 5 6 7 up to infinite. You can take you can use nesting of if. Suppose for example the value of I is 11. For example, the first condition is false because of the value of I is not equal to 10. What do you think? This condition is checked. This condition is will be checked or not? Anyone? If the first condition is false, then the second condition will be checked. The third condition will be checked or not? No, because of if the condition first condition, remember the if statement. If the given condition is true, then only then only the execution is enter into this block. If the condition is false, then directly move out. You can say there is no output. There is no output because of only one condition. You can write here, no problem. Print, write here all conditions. The I is not equal to 10, and the first condition is false. So the execution is not enter into a block. You can see I is not equal to 10. The value of I is not equal to 10 and the first condition is false. So the execution is not enter into the if block. Once the execution is not enter, then how the execution pointer check if is I is less than the value of I is less than 15. The value of I is less than 12, but it is not checked because of first level. You are maybe you are eligible for or capable to crack the second level, but first you have to create you have to crack the first level. If you are not attempt or if you are not crack the first level, then you're not eligible for enter or you are not eligible for appear in the second level. It is not matter whether you are crack or not, but you are not eligible for that. Same here. If the first condition is false, then never the execution pointer is enter into a if block. Getting my point? Clear now? Okay.